Yep.
What happens when you have an intercept at a hole? Do you
Then-
consider it an intercept?
No, it's not. Alright. Okay, so I give you a rational function. I have something on top, I have something on the bottom. The things that you are going to be tested on. Okay? So, you are going to have to find the domain and range. You're going to have to identify the holes and asymptotes. You're going to have to give me the x and y intercepts of the function. You're going to have to find the end behavior and sketch a graph. All of this you should be able to do without the use of a calculator. So here's my question. I'm going to give you about 10 minutes to work together and figure these out. I give you this function. How are you going to find your domain and range? Where and how, where do these occur? And how do you know that it's going to produce a hole or an asymptote? How am I going to give my x and y intercepts? How am I going to be able to figure out what the end behavior is? And then sketch the graph. You can work together. I'll give you about 10 minutes, and then we'll start going over them. Oh, how should you do this? I would go in and look and compare the three that you have in front of you. Take a look, see what's the same, see what's different with the three problems that you've just done. Go. It's okay to talk. I know you people are a little shy. Monday we're going to go over just need to look at the class and probably
It's in these two, right?
if it's a book assignment, you can send it to you. I'm still planning on Thursday, Friday. You guys went Tuesday. I think you're fine.
Is it?
So we'll see.
Find it. why are they?
Monday, Tuesday night.
It'd be like all these
Tuesday
different
night.
holes and I gotta work 7 hours a day. Like 4
It's like this, but slightly bigger.
Yeah, you're right, I am poor. That's why I have a job. That's why I'm working 7 hours a day. Yeah. Yeah. Why do you take that? Yeah, why do you take that?
Because she takes your pizza out.
So, I'd like to do the same thing. You know?
Because you're fast food. She fills up their journeys.
Yeah.
What? Oh, kid. I bet you hate adult
Why? I don't know. I work for my dad anyways.
Carla takes him to basketball. So he's just
After flood or something, take out the wet part and put there, and put everything it's like simple stuff and it's labor, so it's like hard. Get paid like $10 an hour. No, just for the summer.
It's like the NFL.
No, nobody probably he actually hates it. Like, no, I think one of them, I'm not even joking, I think one of them, I think one of the guys, I think it was actually like they met or something.
Alright, couple more minutes.
So he took his car keys and scratched my hands. Yeah. The guy's just an absolute ass. Hard to no go. No one's heard about it. Yeah. He cleaned too much. Kinda. My dad is really pissed.
Your dad's got a big old
Yeah.
Does your dad go to like, I see like the yellow company
All right. So let's talk about these answers. This is where I would take notes.
Yeah.
Write down whatever you need to write down. So I give you some rational function. Okay? G over H. How do you determine the domain of the function? It's not in an inequality, no. Yep.
Isn't it like all rails except for holes and asymptotes?
All reals except for holes and asymptotes. But how do I know where the holes and asymptotes are going to happen? Where what? Where H, in this case, is 0. So my domain is going to be all reals except for the values where H is 0. Right? That will tell me where my holes and asymptotes are at. What about the range? How do I determine the range of my function? Any ideas? Otherwise we can come back to this. I think it's easier to do the range at the end. Identify holes and asymptotes. How do I tell which is which? Zero over 0 is a hole, and a number over 0 is an asymptote. How do I know if I'm going to get a number over 0 or a 0 over 0? Okay, so I factor the top, I factor the bottom. If I have the same factor on the top and bottom, I get a hole. And if I can't cancel them, then it's an asymptote. How do I determine my y-intercept? When x is 0 or the constant over the constant. How do I determine my x-intercepts? When y is equal to 0, and what does that mean? In terms of my rational function. So what, y is 0? How can I tell that by looking at the function where my y values are going to be 0? Where the top is 0. Value of a fraction is 0 when the numerator is 0. So if g of x is 0, I have y-intercepts. Do I have y-intercepts at every spot where g is 0? Why? There could be a hole. Does it have to be either or? Do I have a hole or an intercept?
Yes.
I will have a hole or an intercept at g. That's true, or when g is 0. Yes. How do I find end behavior? What if I'm looking at the exponent? Which exponent? Top or bottom? Okay, what about the exponent on the top? What? How do I determine my end behavior? Okay, I compare the two. I don't look at one or the other, I compare them. Okay, and if I compare them, top and bottom are the same. I'm bigger on top, or I'm bigger on the bottom. Those are your three possibilities for end behavior. So let's say first that they are the same. How do you determine your end behavior if your powers are the same? Is it always 1? No. What is it? The coefficient over the other coefficient. So if I have x squared over x squared, or x cubed over x cubed, or x to the 5th over x to the 5th, the numbers in front, the coefficients on those terms, I'm going to make a fraction of those, and that's where my end behavior is. So if I had 3x to the 5th on top, and I had an 8x to the 5th on the bottom, my end behavior is going to be 3/8. What happens if it's bigger on the bottom? Y equals 0. What's that? The first one is if they're the same. Bigger on the bottom is 0. If they're the same, it's the quotient of the numbers in front. So what happens if it's bigger on the bottom? We said 0. What happens if it's bigger on top? What's that? Yes, you have to divide. Polynomial long division. Ignore the remainder. So let's say that I have x cubed plus 3x squared minus 2x plus 1, and I'm dividing by x squared minus 1. Okay, let's say that I'm doing this and I want to find the end behavior. I have to multiply x squared by x to get x cubed, and then I have minus x. And I subtract, I get 3x squared minus x plus 1. This would give me 3. I'd have 3x squared. Okay? Why do I know that I'm done now? Right. This power is smaller than this one. So I'm done. I don't have to worry about the remainder. So this is your end behavior asymptote, the y equal x plus 3. So when you do your division, whatever comes out at the end, that's your end behavior.
Why did you get negative x if you took negative 2x minus x?
Negative 2 minus negative. Yep. Questions? Oh, we gotta go back and do the range. How do I find the range? Go.
What does the x plus 3 mean? The end behavior asymptote, but what does that mean then?
That means that if you look at your graph, so your graph might look something like this. So x plus 3 looks something like this. So out towards, I need to draw something like this. So my graph might look something like this. Whereas I get farther and farther out to the right, this part of the graph looks like x plus 3. And the other side might look something like this. So as I get closer and closer down here, this graph looks like x plus 3. But it's only out on the extremes. Okay? So, let's go back to domain. Domain, we said x could be anything we wanted except for those values restricted in the domain, which is vertical asymptotes and holes. What values am I going to restrict in my range? What kind of asymptotes? Nope. Horizontal. Right? Think about this. My range values are what? What values? Well, careful. In general, range deals with what values? Y. And y equals lines are what? Like Swivl 3. What is that? Horizontal. Okay? So my horizontal asymptotes need to get restricted out, and holes. Look at your last problem. What happens if I put 6 into that last one? I get a hole. Where's the hole at? 6 what? Where's the Y value of the hole? 12. How'd you get that?
The equation is, it would end up being 0 over -12.
You get 0 over 0 at 6. Yeah. What happens at 6?
As your values go up, they just go ahead 1, so you should be 12.
Should be 12 if you fill in the gap, right? What's the top factor into? X minus 6 and x plus 6. And what happens if I cancel my x minus 6's? What am I left with? X plus 6. Is 6 an issue now? No. 6 and 6? 6 plus 6. 12, the Y value of my hole. So you need to restrict out the Y values of the holes could be restricted out, and the Y values of the end behavior, or your horizontal asymptotes, could be canceled out, or could be restricted out. Take a look at your graph in that second one. I think this. Right? It's my end behavior asymptote in the second one. Actually, let's flip that around. What are my vertical asymptotes? -2 and 2. Does my graph ever cross -2 or 2? No. What's your end behavior asymptote? In the second one, 0. Does my graph ever cross 0? Careful. Where? It does cross at the origin. There's not a hole at 0, 0. I don't think.
No, anyway. No.
So what's the issue then? I don't ever cross at 2 or -2, so I'm never crossing my vertical asymptotes. You just said I had a horizontal at 0. But it crosses at 0. What's the problem? That's an issue. You need to resolve this issue. I can't cross vertical asymptotes. Except at the origin. What if I had what if I had that? What does your end behavior appear to be? Like 3. Does my graph ever cross 3? Yes. That an issue? Yes. Because if I have an asymptote, it's not supposed to cross. What kind of an asymptote is it? Horizontal. And my horizontal asymptotes are what kinds of asymptotes? What? Well, it'd be y equals, but what does it ask you to find? What's it asking you to find? These horizontal asymptotes, what types of asymptotes are they? What's that? They could be oblique, that's one of my possibilities, but the horizontals, you're right, they could be oblique, or they're either oblique or horizontal, but what kinds of asymptotes am I talking about? Read the board. End behavior, which means all I'm concerned about with end behavior, what does this look like on the ends? Out on the ends, they're never going to cross 0. I'm only concerned about what happens out on the ends when I look at end behavior asymptotes. I don't care that it crosses at the origin at 0, 0. So these aren't true asymptotes, true horizontal or oblique asymptotes, like your verticals are. They're only interested in this end behavior. What happens at extreme values, either positive or negative, of x. Hopefully, what's that? It does get closer to 0, out on the ends. But it crosses 0 in the middle. Now, in that first one, in that number 1, and I'm going from memory, so I have something like this, right? So in this one, at 1, I have a true horizontal asymptote. That graph is never going to cross 1. It's end behavior, yes. But there is no place in the middle where I'm going to get 1 out of there. So, take your notes, find me this stuff for 4A. Go. Yep.